My name is and my group will be presenting about flywheel assisted thermoregulated steering system. Okay, have you ever imagined a steering system that's not only smart but also self-regulating under pressure? Introducing our flywheel assisted thermoregulated steering system, a cutting-edge design that combines energy efficiency, thermal management, and precision control. In this video, we'll show you how flywheel technology and temperature regulation come together to improve stability, performance, and safety in dynamic driving conditions. So the first component of need is what key need will you need? The key need we aim to meet with the flywheel assisted thermoregulated steering system is the demand for more efficient, reliable, and safe steering performance in modern vehicles, especially electric and hybrid models. Today's vehicles often face challenges like power limitations, overheating of critical components, and steering lag during high demand situations, such as sudden turns or headwinds. Our system addresses this issue by combining flywheel technology, which stores and delivers energy when needed, with a thermoregulation system that keeps the entire steering mechanism operating with a safe temperature range. By meeting this need, we're not just improving our vehicle performance, but we're also contributing to the energy savings, extending system durability, and enhancing safety for drivers under various driving conditions. In short, we're creating a smarter, more adaptive steering system that supports the needs of future transportation. Thank you.
Hello, my name is Alif. Now I'm going to continue with the second need. This need mainly affects two groups, vehicle manufacturers like Volvo and Scania, and commercial drivers. The companies want steering systems that are more efficient and reliable. Drivers need smoother steering with less effort, especially during long shifts. Disconnect to rotational motion because steering requires torque to turn the wheels. In heavy vehicles, the torque demand is high. Reducing the torque needed means less energy used and less strain on the driver, making the system safer and more efficient for both groups.
Hi, good morning everyone. Okay, my name is Muhammad Ismail. Let's continue to the next component of need. Okay, the problem I'm about to address happens every single day. How often do people experience this and when? Okay, this happens especially for drivers who spend long hours behind the wheel or operate heavy vehicles. Steering becomes particularly difficult during tight cornering, parking, or when driving in hot climates. Under this condition, traditional steering systems tend to overheat or lose efficiency, making the experience physically demanding and uncomfortable. But the issue isn't just about discomfort, it also leads to real cost user. First, there's increased fuel consumption. Inefficient power steering system place extra load to the engine, which means more fuel is burned just to keep the vehicle maneuverable. Okay, second, we have higher maintenance costs because the steering components are under more strain. They wear out faster and parts like pumps, hoses and fluids need to be replaced constantly. And finally, sometimes things that are often overlooked are driver fatigue. When the steering system isn't smooth or responsive, especially during long drivers or in heavy traffic, it wears down the driver. This can result in reduced concentration, slower reaction time, and in extreme cases, accidents. So clearly, there's a significant and far more efficient and thermally stable steering solution. Let's move on to the last component of need.
Hi, my name is Muhammad Nur Ali Berazali. I will explain the last need of a question that asks us about what will happen if that need is not met. If the flywheel assist thermoregulated system is not applied, steering component, especially in heavy vehicle like lorry and truck, it will face high friction and heat build-up. From Physics 210, we learned that friction convert mechanical energy into heat, especially during the long drive or tight turn without proper heat dissipation and part overheat expand. It will cause it to wear out faster due to the thermal expansion. This also increases torque resistance, require more drive effort and leading to fatigue. This is a risk factor for accident, as we explain it in rotation dynamics, or we know that we learn it like rotational motion. Plus, waste energy as heat violate the principle of energy efficient without change, vehicle performance, safely, maintenance and drive health are all at risk. That's all.
Hi. Oh, hi. My name is Tengku Faridina. Now, I will explain about the component of approach. So, our project introduced a flywheel-assisted thermoregulated steering system. It combines two key features. The first one, a flywheel mechanism that captures extra rotational energy and then reuse the energy during correction or sharp turns. This helps reduce energy waste and improve efficiency. Second, the system includes temperature sensors that monitor the steering column head. When the temperature rises, especially from aggressive driving, thermo-responsive material will adjust the steering resistance automatically. This ensures a consistent and safe steering feels and prevent overheating. By combining rotational mechanism with thermal control, this dual-function system offers a smarter, energy-saving and adaptive steering experience, something that hasn't been implemented commercially yet. So, our next component of approach is solution. Our solution is a steering system that combines flywheel-assisted energy recovery with temperature-based resistance control. It aims to improve energy efficiency, prevent overheating and ensure driver safety. When the driver turns the steering wheel, a flywheel captures the excess rotational energy. This energy is then reused during turns or steering correction, so less energy is wasted. At the same time, the system monitors the steering column temperature. If it gets too cold or hot, especially during aggressive driving, the system using thermo-responsive material to adjust the resistance and keep performance stable. Overall, it offers more adaptive and intelligent steering experience, especially in challenging driving conditions.
Okay, so for the last component of approach, do we have any technical issue to solve? Yes, we have a few technical issues to solve. First, we need to design a flywheel that's small and light enough to fit into the steering system, but still powerful enough and release useful energy. If it's too big or heavy, it will affect the steering performance. Second, we need to find the right thermo-responsive material that can react to temperature change accurately without disturbing normal steering. They must adjust resistance only when needed, like during overheating. Lastly, we need a control system that can manage both the flywheel and temperature system in real time. This includes using sensors and programming the system to respond smoothly during fast or aggressive driving. These are the key challenges we must solve to make the system safe, efficient and reliable.